Hey, good morning, everyone. Good morning, friends. So, welcome back to our sessions on machine learning classification algorithms. We have understood the concept of naive, right? So, how naive works, we have understood. And today, we are going to work on a project. Okay, whatever we have learned with respect to naive, we'll apply all of the topics on a use case, right? For that, I'm using Spider. So if you see, this is Spider. I have spoke regarding Spider IDE in my previous playlist, 30 days free short-term training from Python to AI. So friends, in case if you missed it, do watch them. Okay, get some good understanding with respect to the IDE because we cannot again understand from the scratch. Okay, so I have done a video in our previous playlist regarding Anaconda Navigator. So I have also displayed what are the different IDs available, and the ID that I'm using is Spider. Okay, to run my Python code, I'm using Spider. Right. So before we work on the use case, we'll quickly recap what we have covered earlier. Okay, so Naivebase is a classification algorithm which helps us to classify which helps us to work on classification tasks. Okay, it is part of supervised learning. Then, Naive works on probability concepts. Under probability, there is a type called conditional probability. So, can someone tell me what is the formula for conditional probability? Use chat and give me the formula for conditional probability. Conditional probability, generally it can be calculated for at least two or more than two events. Okay, so that means we cannot calculate conditional probability for one event. At least two events has to be there. Okay, so conditional probability is given as probability of A given B. That means you're going to calculate probability of A given event B has already occurred is equals to probability of A and B divided by probability of B. So this is the formula for conditional probability, and using conditional probability we understood a theorem. What is the theorem, friends? What is it called? What is the theorem called that we have come up with to understand the naive Bayes, how naive Bayes works? Naive Bayes works on a specific theorem, okay, in which conditional probability is used. What is it? Bayes theorem. Did not memorize. Yesterday we have also, understood a use case with respect to Bayes theorem. What is the formula for Bayes theorem? Posterior probability is equals to likelihood multiplied by prior probability divided by marginal probability. I told you, okay, many times I'm repeating. See, this is the important formula that we can expect as part of interviews. A question can be asked. Okay, so I'll repeat one more time. Posterior probability is equals to likelihood multiplied by prior probability divided by marginal probability. Okay, right. So we understood the advantages, applications, and all. And today we are going to apply the concepts of naive Bayes on a fish market data set, isn't it? Yes. I'll show you the data first. Okay. Then probably we'll understand the code. How you are going to come up with a naive Bayes model. You see, these are the columns that we have. So species. Okay. So we are going to identify what is the type of fish, what type of species. Then next to it we have our inputs: weight of the fish, length 1, length 2, length 3. Okay, three lengths were being captured. Then height of the fish, width of the fish. Okay, by taking all the inputs, what you are predicting, you are going to predict the species, the type. Okay, so let us also get understood with respect to these features. Okay, I have also gathered the data dictionary. I'll share you the data dictionary as well. See, this particular data set is from market, okay, which is related to fish. Okay, so and we have the common attributes like species, what is the type of the fish, category. Okay, then weight of the fish we have it in grams. Okay, then length 1, length 2, length 3. So three different lengths were being captured, right? What are these three lengths? Length 1 talks about the vertical length of fish. Okay, the vertical length of the fish in centimeters. Then length 2 talks about the diagonal length. You are considering the diagonal length of the fish in centimeters again. Third length talks about the cross sectional length. When you take a cross section of a particular fish, okay, the length was captured and it is also in centimeters. Then height and width. What is the height and what is the width? So these are the six attributes, six inputs that we are going to use to predict what is the category of a fish we are going to predict. So let us implement the same crisp mlq methodology. Okay, first of all, did we understood the data? Yes, data understanding was done. Okay, now we are supposed to start data preparation phase. Okay, in order to load the data or in order to manipulate the data, first of all I should load some important libraries. Libraries should be imported, right? So what am I doing? I'm importing pandas for data manipulation and analysis as PD. So giving an alias name. So imported pandas as PD. Okay, successfully imported. Then next to pandas we have numpy. I'm importing numpy for numerical calculations. In order to do any basic mathematical calculations, I can use numpy module, right? So I'm importing numpy and giving an alias name as np. Third library that I'm importing here is cborn. What is the use of cborn, friends? Cborn is used for visualization. Okay, so I'm importing cborn as sns, giving an alias name as sns. Done. Then what is the next module that we are importing? We are importing matplotlib.pyplot. Okay, so within matplotlib, I'm importing a submodule. A sub package is being imported. Okay, so what makes the difference between line number 26, 29? What is the difference? We have already discussed these two lines in our earlier sessions as well, right? So what is the difference between these two? I'm importing matplotlib dot pyplot. That means I'm not importing the matplotlib complete matplotlib module, but I'm just importing only a sub package. Okay, so let me go and do it. Yes, it's done. Okay, so that means we just imported matplotlib.pyplot. Only pyplot from matplotlib was being imported. Then, so again for plotting, for visualization, we have imported pyplot. Next to pyplot, we are going to import label encoder. What is the purpose of label encoder, friends? So, friends, majority of these functions modules that I am discussing now were already explained in the previous module. If you fail to go through those sessions, my sincere request is please go through those playlist. Okay, please go through those videos. Once after you have a clear understanding on those topics, then come back and understand these projects. The main reason for it is, as part of this project, we'll do EDA, data pre-processing. Okay, and we cannot explain from scratch, right? So time again, if you keep on explaining the same, that would not make any sense. So what am I doing? I'm importing only label encoder from sklearn.preprocessing. Label encoder is used for encoding, converting categorical data into numeric data, generally used on outputs. Done. What am I importing next to label encoder? I'm importing profile report, which is pandas profiling, which is from pandas profiling. What is the use of pandas profiling? Pandas profiling is an automated EDA library. Okay, so it automates the entire EDA process. We need not calculate first moment, second moment, third moment, fourth moment individually, and moreover, the data visualization is also not required. All the steps together can be done by just using a single library, and those libraries are nothing but auto EDA libraries. Okay, so one of the important and widely used auto EDA library is pandas profiling. Okay, all right. So let me import it. Done. Yes. See, installing is different, importing is different. There is a lot of difference between importing and installing. Okay, so if you when you try to import it and if you get an error, that means you don't have that particular library installed in your current working directory. Okay, so you are supposed to install it, friends. Right, how do we install? We use either pip or conda tools to install the packages, the libraries. Then next to pandas profiling, we are importing winsorizer from feature underscore engine dot outliers. From feature underscore engine dot outliers. Imported? Yes. Then what are we doing next? I'm importing min-max scalar for feature scaling from sklearn dot preprocessing. Imported. Then train test split is being imported from sklearn dot model selection. In order to split the data into components, train dataset and test dataset, we are importing train test split. Then Gaussian NB. This is the function which helps us to create a Gaussian naive-Bayes model. A naive-Bayes model can be built using this particular function. So where is this function available? It is present in sklearn library. sklearn library is an important library that one should be aware of. If you are especially looking out for, not to do projects on machine learning or AI, deep learning, ensure that you are good at sklearn library. because majority of the functions are available in sklearn. Okay, so from sklearn.naive naive underscore base, okay, I'm importing Gaussian NB. Then next to Gaussian NB, what are we importing? I'm importing accuracy underscore score, classification underscore report, confusion underscore matrix. So I'm importing three main things. One is accuracy score, classification report, then uh, confusion matrix from sklearn.metrics. So sklearn is the library, metrics is the sub library, sub package. Okay, from this sub package, I'm importing all these three. Done. And finally, in order to tune my model, in order to get better results, I tune my model, and for that I'm importing grid search CV from sklearn dot model underscore selection. Okay, and next to grid search CV, we'll also import smote, which is used to handle, imbalanced data sets. If we have imbalanced data sets, okay, then smote helps us to balance it. Okay, what is the full form of smote? Synthetic minority oversampling technique. Okay, so it's an oversampling technique which helps us to generate synthetic samples for the minority class. Okay, so I'll talk about smote when we execute the line of code. And finally, joblib friends. Joblib helps us to save or load the models. The models that we are going to, come up with, they can be saved using joblib package. Right. So I have done with all the modules, libraries, okay, were being imported. I'll start working on the data set. What am I doing? I want everyone to respond, don't sit idle. Okay. So these are not something new for us, because in the previous sessions we have already learned these steps. What am I doing in line number 42? I want everyone to respond. What are we doing? Loading the data set. Good. See, I'm loading the data set. Okay. How? Using a function. What is a function? The function is read underscore CSV. Okay. Akhil, how do you say it is a function? Friends. See, for a function, you'll have parenthesis. Okay. So it is a function. This function comes from PD. What is PD? Pandas. PD is nothing but pandas. So, in simple, using pandas, there is a function that is read underscore CSV, which is used to read CSV files. Since the data that I have is stored in a CSV file, I'm reading this data, I'm loading this data from a CSV file into a data frame. Okay, so you just specify the path. Once after specifying the path inside the function, okay, so ensure that you also use R in front of the path. This R makes sure that the entire path will be read by the interpreter in the raw format. Okay, what if you don't use R? If you don't use R, there is a chance of getting Unicode error. What is this Unicode error? Unicode error means, as part of the path, the file path, you may have any special characters. So what happens is, when Python interpreter, when you execute this line of code, Python interpreter get confused, and, you know instead of reading it, It takes the meaning of this special character. Okay, so that is the reason it is always recommended to specify it. This is the best practice, specifying R in front of the file path. So once after reading the data will be stored in a variable, and the variable is nothing but df. So let us see what is the size. The size is 159 rows and 7 columns. Is it done? Yes. So let us open our data frame. This is our data frame. See. Okay. Right. What am I doing in line number 45? What are we doing in line number 45? Be active. We are getting the top 5 records. Head function will return the top records. How many records should be returned? 5. Okay, so this will return me the top 5 records. Akhil, what is the advantage, or what purpose did you use for? What is the purpose that you have used head function? So friends, when you have millions of records, and if you want to just go through your data, will you go through all the millions of records? Foolish, right? So what we do, we just go through the top records. That is enough to understand about the data, right? So head function is used in such scenario. In the same way, info function, what does info function does? Info function will return the information about the data set, like column names, data types, the count, the normal count and all. What are the column names? Okay, it also talks about the non-null count. So that means all the columns have 159 non-null values. So what do you say? I get an insight from here. The insight is there is no null value in any of these columns. There is no null value. Okay, then if there is no null value, should I do imputation as part of data pre-processing? Not required. Why, my friend? What is the use of doing data imputation if there is no null value? Right? So this info function will return the column names, the non-null count, the data types, the columns, rows, and all. Okay. Then shape attribute. What does shape attribute return? What does shape attribute return? Shape attribute, it returns the dimensions, number of rows and number of columns. Akhil, why are again using shape attribute? What is the use of using shape? Anyhow, you are able to see the shape size here, right? Why are you using shape? If that is your question, friends, only in Spider you'll have this feature. Okay, the size of the data frame can be displayed only in Spider. If you go and use any other IDEs, no other IDE will give you the same user interface. Okay, and moreover, no other IDE will give you the same features. So in that case, if you want to know what is the size of your data set, what is the shape of your data set, so obviously you should go and use shape. So I'm not, you know, doing some silly steps. We are not working on some silly steps. We are actually understanding different functions that can be used in different ways. And moreover, these are very important at the beginning part itself. Okay, then next to shape we have the EDA part. So as part of EDA, what am I doing? I'm using profile report, okay, which we have imported from pandas profiling, and this pandas profiling is an auto EDA library. So this profile report, what does it does is it completes the entire EDA in just 2 lines of code. See, I'm just passing the data, that is df, okay, and I'm giving a title to it, naming it as pandas profiling report, and explorative is equals to true. So I want to explore to the values of the output. Okay, so when I execute it, see what happens. Execution done. Now I want to save the results to a HTML file. I want to save the results to a HTML file. So what am I doing? I'm going to save that two underscore file using two underscore file function. I'll get the result saved to a HTML file. See, you observe the console how it's taking. It is getting executed. Observe the console. So it may take time, but it completes the entire EDA process. Calculation of first moment, second moment, third moment, fourth moment, and graphical representation as well. Is it done? Yes, it is done. So where do we have the output? You go to your current working directory. How do you know that what is your current working directory? It will be displayed here in Spider. So in this path, you will have all the files that was saved from the script. So I'll go back to my current working directory, and if you see, this is my HTML report. At what time it got generated? It got generated just now, 11:57. So let me double click on it. So this is my output of pandas profiling. Can you get the complete information? Yes. See, number of variables, number of observations, missing value 0, missing values percentage 0. Okay, what is the total size in memory? It is occupying 17 KB kilobytes. Okay, out of these seven, how many of them are categorical? How many of them are numeric? Okay, yeah, wish each and every point you can study. If you take one column, okay, what are the distinct values present in that column? The percentage of distinct value, missing percentage, infinite values are there? No. Okay, what is the infinite percentage? Mean, what is the mean value? Zeros, if there are any zeros values? No, zero. What is the maximum value, minimum value? Zeros percentage, again zero, negative values, negative value percentage, memory size. Each and every important point, okay, with respect to the columns have been displayed in the output. And finally, the histogram in order to understand the distribution. See, if you would like to do some interactions, yes, we have scatter plot as also. Okay, width, right? So let me take length one with width. What kind of relation you observe here, friends? With respect to the scatter plot, what do you say? Is it strong, weak, or moderate? Anyways, if I keep on talking about all these things, it would take more time. See, if you observe carefully, the scatter present in this area is tightly packed compared to the scatter present in this area. There is a distance between the scatter in this particular area, but here it is tightly packed. So I say it as strong relation. Okay, the main reason is the scatter is very close to each other, and moreover, since the scatter is going in a upward direction, we can say it as positive. Okay, I assume that R value will be greater than 0.85. Okay, so obviously it will be strong and positive relation between width and length one columns. In this way, you can change, you can interact with other columns as well. Okay, then correlations can be understood. See, width with length one, so probably it's around zero point 0.7 greater than 0.75. Okay, so that is the reason you are able to see this color. And for the diagonal, you'll have one. Why? Diagonal is talking about relation with the same column. Okay, then we have missing values, no missing value present in none of the columns. Okay, then finally a sample of the data is also provided. The first 10 rows and the last 10 rows will be provided by default. I hope it's making sense. So this is a very important auto EDA library. It's pandas profiling. Okay, so you're supposed to go through the documentation of it in order to get an good understanding regarding the package. So these are some insights that we got from the plot. No missing values, no duplicates. There is no duplicate also. Okay. Now, what am I doing? I'm separating x and y. Why should we separate x and y? Friends, if you separate x and y so that on x, nothing but inputs, you can do pre-processing steps. You can complete the cleaning part. Okay, we are not supposed to clean output column. Output should be as it is. Okay, so what am I doing? I'm going to drop the y column from df, so that will give me only inputs, and these inputs I'll have in stored in x. These inputs I'll store it in x. So if you see here, so what is the size of x? 159 comma 6. df is 159 comma 7. So one column has been removed, that is y column. Let me store y separately. Okay, that is nothing but species. I am storing this species separately in y. So if you see, y is a series which is a single column. Only it's 159 records. So that means only one column. So this is y and this is x. Now once after separating both of these, let me get the value underscore counts. Okay, the value counts for y column. So this value counts will return the count for each and every distinct value present in y column. Where are we storing it? We are storing it in a class underscore counts variable. So let me print it to the console. So in total, how many classes do you have inside your y class, y variable? I have 1, 2, 3, 4, 5, 6, 7. There are 7 types of fishes available in our y column. Okay, there are 7 types of fishes available in our data. So for better understanding, what I'm doing is I'm plotting a you know kind of count plot. So if I go through this plot, I can obviously understand well. There is a proverb, if you remember, a picture speaks thousand words. So if you look at this visualization, what do you understand? Obviously, out of all the types, whitefish has the count of whitefish is very small, and the count of perch is more. Okay, so this is how the types of fish. Okay, we have the count in our y column, so that means we can clearly say the data is in imbalanced state. The data is not balanced. Okay, so what do you mean by balanced, imbalanced? When do you say data is imbalanced, my friend? When do you say data is imbalanced? I want everyone to respond. When do we say data is imbalanced? Okay. When you take your Y column, okay, in Y column you'll have the classes, right? No, 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 not exactly. See, in Y column, these are the values that we have, my friend. Okay, so we have 7 types of classes available in our Y column. If all the classes have at least 30% of the values, what is 30% of 160? Assume this value is 160 rows. So 10% is 16. 30% will be 48. So all the classes that we have in the Y column, if they are at least 48, each and every class, if they have 48 values, am I right? Sorry, it's 100% is 160, 10% will be, yes, that's it, 16. Okay, so we should have at least 30% of the values for all the classes. Only then we can say that the data is balanced. But if you see here, is the data balanced? You see whitefish, it is very less in size. The values that you see for whitefish is very less. So the data is clearly, it's in a stage of imbalanced. So what we are supposed to do? We are supposed to balance it, and we are going to use SMOT as the technique for balancing it. Okay, but before balancing, I would like to do some kind of data pre-processing steps. For that, what am I doing? I'm going to check the box plot. Okay, do we have outliers in any of the columns? Yes, I have outliers in weight, length 1, length 2, length 3. So what we are supposed to do? We are supposed to remove them. I'm using Winsorizer function, and the method I'm keeping as Gaussian. Okay, and I'm passing all the list of columns. So this will ensure that the outliers get treated. So I'm just initializing Winsorizer. Once after initializing, I'm going to use it on inputs. I'll apply it on inputs where it fits and transforms the data of inputs, and the inputs get cleaned. Done. Now again, to cross check, what am I doing? I'm going to visualize box plot again, but on cleaned data. Okay, so now, do we have any outliers? No, all of them got treated. No outliers anymore. So they got treated. Yes. Once after treating the outliers, I am going to scale the values. Okay. I am performing feature scaling technique, that is min max scalar. So I'm initializing min max scalar in line number 102. Okay. And this, after initializing, I stored it in a variable scalar, and this becomes my function now. Okay, using scalar, I'll fit on the data and I'll transform it. The function that we use is fit underscore transform. So this is going to transform the scaled data. I mean, the data gets scaled, and you're storing it in scaled underscore x. So let me show you scaled underscore x. So this is the inputs that we have. All of them will be between 0 and 1. The reason is we have used min-max scalar. If you remember min-max scalar, my friends, the output of min-max scalar will be minimum value present in all the columns should be 0 and maximum value should be 1. These are the default range for min-max scalar. Right. Next to min max scalar, what am I doing? I'm converting the target, the values that are present in the y column, target column. I'm converting these categorical values to numeric values. How? Using label encoder. This label encoder helps us to, excuse me, encode the values. Okay, so I'm initializing label encoder. Then where did I store? I stored it in a variable le. So using le, I'll fit on the y column and I'll get the transformed results, and these transformed results will be stored again in y. So let me go and check y. You see, previously we have the type names, the category names, but what they got converted to numbers. I hope it's making sense. Okay, so far we just completed the data pre-processing steps only, my friends. Only data pre-processing steps got completed. Okay, now what are we supposed to do? We are supposed to build our model. Once the data got no cleaned, the third step comes into the picture of CRISP MLQ. Third phase, model building. In order to build my model, what is the first step? The first step says you have to split the data into two parts. What are the two parts? Train and test. So what am I doing? I'm passing scaled x and y, both inputs and output, and I'm going to break them into two parts. Test size is equal to 0.2. That means test size will be 20%. Then what would be the train size? 80%. Am I right? Yes. So let us split our data into two parts, train and test. So this is going to split our data into two parts, train and test. Akhil, that's fine. If it is two parts, why did you mention four variables here? What is the use of four variables? Friends, in these two parts, train and test, in each of the part, you'll have inputs, output. Yes. So train inputs, x represent inputs, right? So under train data, the inputs will be stored in x train. Under train data, the outputs will be stored in y train. The same, under test data, the inputs will be stored in x test. Under test data, the outputs will be stored in y test. Okay, so that's how you are going to break your partition the model. I mean, partition your data. Just let me, you see the four variables: x test, y test, x train, y train sizes. Okay. Once after completing the train test split, what is the next step? You are supposed to build the model, but before that, I'm using Smart in order to balance my training data set. I know that the data set that I'm using is imbalanced, but if you build your model on imbalanced data sets, the results will be worst. For that reason, we are converting. Okay, we are applying SMOT. SMOT stands for synthetic minority oversampling technique. Okay, it's an oversampling technique which helps us to generate synthetic minority samples. The minority class will be observed, and synthetic samples, synthetic instances will be created by oversampling it. Okay, so I'm using SMOT, I'm initializing, and I'm applying it on the test data set, sorry, train data set, so that the values will be raised. If you observe properly here in the output, uh, what is the size of x train? 127 by 6, right? So I'll run this particular line of code. You see what happens to x underscore train underscore smart. See, x train is initially 127 rows, 6 columns, but x train smart is 315 rows, 6 columns. So what happens is When you apply smooth, oversampling technique happens. Oversampling happens for the minority class, and synthetic instances will be created. Okay, that the minority class will be observed, and the synthetic instances will be created in order to balance the data. Once the data got balanced, you can start building your model. What am I doing? I started building my model, and it is Gaussian NB. It's a function. Gaussian naive Bayes is what we are using. What is the assumption that Gaussian naive Bayes holds? Gaussian naive Bayes assumes that the inputs that we are taking to build the model, okay, it should be all the inputs should be normally distributed is the basic assumption that Gaussian NB assumes. Okay, so what am I doing? I'm initializing the model. The model got initialized, the function. Then next to it, I'm using this function. I'm going to fit on the data. What data? The data that we have obtained from Smoot. X train Smoot, Y train Smoot. Okay, so once after you know we completed fitting, the model gets created in the backend. Using this model, the model is stored in the same GNB. So what I'm going to do, I'm going to use this model and predict on the test data set. So what you get predictions. That's what we have understood as part of ML primer. When you predict, when you use your model and predict on the test data, you'll get predictions. Okay, you have predictions, you also have actual. When you have both, you can calculate accuracy. What you are doing here, you're calculating accuracy. What is the accuracy on my test data set? It is 59 percentage. So it's not that much good, right? 59% is the worst case. The model is not working well. So that means there is a chance of 41% the model going wrong. If error is 41%, obviously accuracy will be 59, right? So it is the bad model that we have got. So let us not take this. Anyhow, we'll tune the model. But before that, we'll also get the classification report. So this is the classification report where we see precision, recall, F1 score for all the classes. Okay. And finally, the confusion matrix. So this is the confusion matrix. The confusion matrix holds the true positives, false positives, true negatives, and false negatives. So it will be hard at this point of time to explain what is confusion matrix because this is a 7 class problem. This is a 7 class problem. So it's better if we understand confusion matrix initially on a 2 class problem. That would make sense. So I'll explain confusion matrix in the next project, probably in the next algorithm, decision tree might be, right? So I'll do the same on train data set as well. I'll get the predictions like whatever we have done on test. I'm going to do it on train. I'll get the predictions. I also have the actual, so I can get the accuracy. The accuracy on train data set is 73 percentage, my friends. On test, it is 59. On train, it is 73. Anyhow, this is not a good model. So let us not consider this. Okay. Let us also get the classification report. Then finally, the confusion matrix on train data. So all things we have calculated with respect to the model building part. The model building was done using Gaussian naive Bayes. Once after building the model, we have got the predictions on test data. We calculated the accuracy, test accuracy. The test accuracy is very small, that is 59% only. Then the same steps were being carried on train data as well. Okay, So we got train accuracy as 71 percentage, better than test, but somehow it is not that much good. And we also got the confusion metrics on the train data set. Right. Now, what am I going to do is, as the results that we got are not that much good, okay, let us do some hyperparameter tuning. What is this hyperparameter tuning? It means you're tuning your model to get better results by changing the hyperparameters. Okay, so these hyperparameters will differ from algorithm to algorithm. Okay, hyperparameters will differ from algorithm to algorithm. In naives, we have the hyperparameter. It is where smoothing, nothing but the Laplace coefficient. What am I doing? I'm taking a range for this Laplace coefficient, that is minus 10 to 0. I want to create 50 values. So it calculates the logarithmic values for uh, minus 10 to 0. Okay, so 10 raised to the power minus 10 to 10 raised to the power 0. By taking the logarithm values between these range, it is going to calculate 50 values, and all these 50 values will be used as part of our hyper tuning process. So what exactly are we going to do as part of hyperparameter tuning? I'm using a technique called grid search CV. This grid search CV helps us to come up with all the possibilities. All the combinations will be carried out, and the best combination will be given as output. Wherever it identifies the best results, the best combination will be given as output. So what am I passing to this grid search CV? I am passing estimator as Gaussian naives. GNB is nothing but our Gaussian naives. Then param grid is nothing but our Laplace coefficient, where smoothing. And CV represents cross validation, which represents a k-fold cross validation. So this particular data set will be made into 5 parts, and each part will ensure that it was used as test data, and rest of the 4 parts will be used as train data. Okay, so cross validation helps us that each and every record will experience once at least as a validation data set. And what should be considered as part of scoring? It is accuracy. And verbose, one will result all the possible outcomes. So this grid I'm executing, initialized. Now, once after initializing, what am I going to do? I'm going to use this grid and fit on the train data. On the train data, I'm going to fit. Once you see here, it started, all the possible combinations were being carried out, and let us get the best results out of all these combinations. Let us get the best parameters. So these are the best parameters. What is the best parameter? If the var smoothing is 0.095, okay, so this is where the best results were being obtained. What is accuracy? The accuracy is 73 percentage. Previously it is 71 only. It got increased, right? So in this way we tune our model to get the best results, my friend. Okay, so I'll carry out using the best estimator. I am going to extract the best estimator, and this best estimator is stored and used on test data set to calculate the score. The accuracy score will be achieved, okay, on test as well as train. Okay, and let us also print it. So on test it is 62%, on train it is 74%. Making sense? Are they increased? Yes, they got increased. Compared to the previous case, yes, a bit has been increased. 74% on train accuracy and 62% on test data set. Okay, so if you feel that the model is performing well, you can store that model for your future data. What we do is we use joblib. Okay, joblib package will be used, in which there is a function called dump, and this dump function is going to store the model. Which model? Best underscore gnb, this one. Okay, so we are going to store it, and we are going to name it as best underscore gnb dot pkl. Okay, so this is the name that we give to the file, and we are opening it in wb represents write binary. Okay, so it writes this file in the format of binary, in the binary format, and stores the model, and this model can be used in the for the upcoming data. Excuse me. Okay, so this is an end-to-end project on Navies. You can do the same task can be applied on different projects. Okay, if it is especially a classification data set, if you're working on a classification task, yes, go and use Navies. Okay, upon your inputs, upon the features that you select the type of Navies that you are going to use. So with this, we have successfully completed a project on Navies, and this is going to. I feel that these accuracies are okay for me. If you feel that these are not satisfying, the results are not satisfying, you go still do hyperparameter tuning. Okay, change the parameters. If you feel that the values are increasing, that's okay. If not, for this data set, probably Naivbase is not giving the right results, then we will switch the algorithm itself. Okay, so friends, by just looking at the data set, you cannot assume or you cannot say that this algorithm works well or that algorithm works well. You have to experiment. So everything is like experimenting only. When you experiment, if the results are good, then obviously you'll take that model into consideration. If not, you'll take some other model, you'll take some other algorithm. Okay, this is what we do in real time. In the sense, we experiment, we keep on experiment. When we do a lot of experiments, at some point of time, the results will be good, and that results will be considered. So that result should also satisfy the client. Okay, so upon the domain, the result should satisfy, and if they're satisfactory, yes, we'll deploy, and then the model monitoring and maintenance starts. Okay, so I hope we had a good session today, because lot of new things were being understood, and even many of us have interacted well. My friend keep on interacting. So thank you so much. And from tomorrow, probably we'll start one more new classification algorithm, and we'll do in the same way. We'll understand the theory part, then we'll go and do a hands-on. So before you leave, if you find the session is really great, hit on the like button, do share. Okay, and if you have any kind of questions, yes, you can also use the comment section to shoot your questions. Right? Yes. So that's all for the day. Again, we'll meet in the next session. Until then, take care. Have a great day. Bye.